Hi, so what I'm going to do today is show you how to use the conjugate root theorem. So this is the conjugate root theorem. So if a plus bi is a root of some polynomial which has real coefficients, then a minus ib is also a root. So remember, this a minus ib is a conjugate of a plus bi. The sign has changed. So here's an example of a question where we could do this. So prove that 1 minus I is a root of some equation, and then we can hence find the other roots. So to show that it is a root, we can substitute this into that equation and show that left hand side and right hand side are the same. So what do you get? 1 minus I cubed minus 3, 1 minus I squared plus 4, blah, 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 blah. So let's expand this using our binomial expansion. We can expand that quickly, expand that. This is what we would get. So using a binomial expansion, you know the coefficients are going to be 1, 3, 3, and 1. We know the signs have to alternate between negative and positive, so negative, positive, negative. And because that's a 1, it's a nice, we don't have to worry about the coefficients too much. Of that expansion part, this I, negative I cubed, so we'll have an I to the power of 0, I to the power of 1, I squared, and an I cubed. Expanding that's pretty simple, and expanding that out. So what I'm going to do now is I'm going to change some of these and then simplify it. So really that I squared is a minus 1, so that becomes a minus 3. I cubed, you know, is I squared times I. Now I squared is minus 1, so that becomes a positive I. Now this might be another line of working you right underneath. I squared is a minus 1, and let's expand it all out and see what we get. So we get 1 minus 3i minus 3 plus I minus 3 plus 6i plus 3 plus 4 minus 4i minus 2 equals 0. Now let's group like terms. So minus 3i plus I is minus 2i, plus 6i is plus 4i, minus 4i is a 0. 1 minus 3 is minus 2, minus 3 is minus 5, plus a 7 is plus 2, minus 2 is a 0. So we get 0 equals 0. So therefore, 1 minus I is a root. Now, the conjugate theorem states that if that is a root, then its conjugate is a root. So therefore, 1 plus I is also a root. Now, if you have a look at the original equation, we've got a cubic here. Now, a cubic has 3 solutions. We already know what 2 of the solutions are, these 2 here. Now, the beauty about conjugates is that when you add them together, the i's disappear. So let's have a look at the sum of the roots taken one at a time. So the sum of the roots taken one at a time is minus b on a. So it's a 1 plus I, that's one of the roots, plus a 1 minus I, plus an alpha equals minus b on a. So b is minus 3, so negative negative makes that a positive, over a, which is a 1. So that cancels with that. We get 2 plus alpha equals 3, so we get alpha equals 1. So therefore, the solutions to that original cubic is 1 plus or minus I. You can write like that because they're conjugates of each other, and 1.